Okay, so I'm going to recap here. You notice that some of this is already written. We had the video fail partway through, and instead of retyping everything, I'm just going to do a quick recap. What I'm talking about is if statements. It's one of the basic constructs that we have in C++, and it allows us to execute code based on whether a particular piece of logic needs to be executed or not. So what I decided is let's make a little program that takes in a number and grades and assigns a letter grade to it. And so I created an integer called iScore, and I initialized it to 0 because it's always a good practice to explicitly initialize your variables when you declare them. That way we know what's in the memory location. Especially with older compilers, you'll find that if something is not explicitly initialized, oftentimes before you put your values in there, it could have junk from whatever was in that memory location previously. And compilers and computers don't always initialize things properly, so to always have a known value in there before you start, we tend to initialize things with a value. So I created a prompt that said input student score, and then I'm going to accept in the score using the CN. I also mentioned, I made a note down here that we do not need to return 0. If you remember my previous videos, they had a return 0, and that is the last line that we have in main or any function if that function has a return data type. In this main, I use the keyword void, which means that there is no return data type. So that way I do not have to put that return 0 down there. If you ever create a function, and you will create functions later in the course, and you have a return type on it, at the last thing in your function has to be return and some value. If you want a function that doesn't return anything, then we use the keyword void, which means we're not expecting anything to come back out of this function. So let's go ahead and write some code. Now, what I'm going to do here is this is an example of one way to solve the problem, but it is not the only way. In fact, this type of daisy chain of code may not be the best solution. So, and this isn't the best solution. We're not going to talk about the best solution here because it's more advanced than where we're at, but this will help us for now. All right. So now let's go ahead and I'm going to say if iScore is greater than or equal to 90, okay, and I don't know if it made it into this particular recording or not, but I had mentioned that I was just going to make it really easy and say 90 and above is an A and 80 and above is a B, only because I think it's a whole lot more simple than say the grading score schema that we're using in the course, and we want to keep this simple. Okay, so now if it's greater than or equal to 90, I'm going to do something here. So I'm going to say I always create my brackets first because that way I don't have a problem with forgetting a bracket and then having a bunch of bugs. And then what I do on the closing bracket is when we get hundreds and hundreds of brackets in a program, it can be really hard to pair them up. Even though we have some fancy things now that'll highlight the brackets that belong together. Problem is that only works if your code is right. See how I did that? Now they're both highlighted. If we have a bunch of messed up code, that may not be the case, and they may not highlight properly. So they may be pairing the wrong brackets, and that really confuses you. So what I say, this is going to go with if I score greater than or equal to 90. Okay, I don't have to put the whole thing. It's just enough so that we know what the heck it's about. Or I could just put greater than or equal to 90. And so I'm just going to do a cout. I'm going to say grade is A. and I'm going to say C out. Very well done. Okay, so now I have one if statement, and actually I've got enough here where I can actually run this. So I could say I'm going to start without debugging. I'm going to talk about debugging in a little bit. So it's building, and it's running, and I got to bring this over here. Student score is, I want to put in, they get a perfect 100, and your grade is A. Press any key to continue. Okay, so that little bit is called bench checking because I was able to test a partially written program to make sure that it works. Now that'll only work if you have perfectly well set up logic within your partial program, and so that's a skill that you'll learn. One of the things I'm going to do is I'm going to indent the brackets here because typically we like to indent a little bit, and it helps to make things more readable. So now I'm going to do this. I'm going to make a common student mistake here, and I'm just going to say if I-score greater than or equal to 80. I'll put a couple of curly brackets. You notice how it kind of auto indents at first, and then I just kind of pop them back over there, and then I'm going to put just over here greater than or equal to 80, just like that. And I'm going to say C out grade is B, and line C out you are above average, and line. Okay, so now I like to save early and often, so I'll just save that, and let me run this. And I'm going to debug, start without debugging, and it's going to ask me if I want to rebuild it. It has to be rebuilt because I added more code. So it's going to rebuild. Now I'm going to bring this over here, and I'm going to put in the same 100. Grade is A, very well done. Grade is B, you are above average. So let's look at why we have this seemingly strange behavior. It's showing that a 90, or 100% I should say, is an A and a B. Well, let's figure it out. So the answer to this is actually, it's fairly simple. And the answer is that what we have is a situation where we have two completely separate logical constructs that are using an if statement. And so what that's doing is it's causing the following to happen. Now I'm going to show you something here. This is a good segue into using the debugger. And the debugger is actually a really cool thing because I can literally watch this code execute in real time by stepping through it, it's called. Alright, so what I'm going to do is I'm going to go up here at first, and I'm going to see step into and step over. For now, let's just do step over. Okay, so I'm going to hit F10, and it's going to start things up. So I'm going to hit F10, and you can see, if I don't know if you're going to be able to see it all. Let me try to make this a little bit smaller because it looks like it's off the edge of the recording. Right here, there's this little yellow arrow, and what's happened is the program is now running, and it's running. Let me see if I can just size this a little better. It's running and stopped at that point right where that arrow is. And so by repeatedly hitting F10, I can actually watch each line of this code run. So I'm going to hit F10, and look at here. I've stopped at where it's about to declare I-score. Now look down here. This is called an output window, and it says I-score, and it says a weird value in there, negative 85 gazillion something or other. Okay, that's what junk that was in that memory location right now. So after I hit I-score and go past it, I hit F10 again, I should say, and go past it. Look, it's showing me the value that's in I-score, and I could actually just put my cursor over it too and see I-score. So I'm now at the C out, and let me slide. I actually see this window right here is actually up as well, and so it's asking me to input the student score, and I'm going to have to make this input window disappear in a minute. So I'm going to have to say one. If I try to type right now, okay, it won't work. Well, because I have to make that move that off the screen for a second. Hit F10 until I get past the I score. Oh, that was me just having my finger on the keyboard. And I'm going to put in 100. I'm going to hit enter. And now we're back right here at this first if statement. So it's going to execute this if statement. If I score is greater than or equal to 90, and it sure is, it's going to do those two C outs. Okay? And I'll just pop that back up. It's actually, it just minimizes it, so I just brought it back up. Very well done. Well, now I'm going to come down here, and I'm going to run. And look at this. It's running the second one and comparing it. And is 100 greater than or equal to 80? Absolutely it is. That's why both of these are running at the same time. And we don't want that to happen. So we have to use a slightly different logical construct. So I can just stop this debugging by just hitting this little red square here, and that stopped it. So now we're back into input mode. And what I can do to fix that is to chain these if statements together into one logical unit. All right, so I'm going to put in on this second one keyword else. Instead of these two if statements being separate if statements, they are now part of the same logical unit. And as soon as the first one that is correct executes and all of the code inside it executes, this chain together if set of if statements using the else keyword will short circuit and the rest are not executed. So this executes, keeps going down through the list until it finds one that is true, and then executes it and then short circuits. So let's do an F10 here again. So I'm going to have to rebuild it because I changed it. So I'm going to use F10 and see it pops that up, but it kind of makes it disappear for a minute. And I'm just going to step down here real quick. Type in a student score and put 100. If score greater than or equal to 90, sure is. Got an A. Looky here, we didn't go down to the else. It short-circuited and went to the end of the program. And I hit F10 again, and actually this is a good point. If you start seeing weird stuff that you don't understand like this, it did a step into, and so all you have to do is just stop debugging, okay? And I can just close that X, hit the X there to close out that code behind stuff. And so now I've correctly fixed up this problem that I had with both of those running at the same time. And so all I have to do is else if I score greater than or equal to 70, then I'm going to do something else here, okay? I'm going to make another mistake so I can show you it. See out, grade is B, C I should say, ENDL. This is a common mistake too. You are average student. Not grammatically correct, but you get the idea. All right, so now let's run this. I'm not going to debug it. I'm just going to run it. Okay. So let's do this. I'm going to say this student got a 68. Okay. Nothing happened. That's expected because it's less than 70. Okay, so that worked. So I'm bench checking. Okay, I'm doing a bench check by just testing. So I know that the lower bounds is working. So let me try a 70. Graded C. You're an average student. Press any key to continue. Okay, so that works okay. So let's continue. And my mistake is still there. And I'm going to say I score greater than or equal to 60. Then I'm going to say And you may have figured out by now that my problem, what it is. So you see out. And get my typing skills back here. Alright, so I typed that in. And of course I could put my little note down here if I want to. I could say and I suggest you do this on all your homework, and I'll probably comment on it as well if you don't, because I'm going to save you some grief. Well, look at this little red problem here. Error expected a statement. What in the heck is going on? Well, what is going on is I forgot to put in these brackets. Okay, and that has a very important consequence. Well, here what's happening is it broke that chain and it threw in a statement that had nothing to do with that if. This is an important point, and this is go ahead and indent those. Okay, now this is correct. The issue becomes these brackets are what delineate which code is executed based on whether this particular part of the if statement is true or not. If you leave out the brackets, the only thing that is associated with this part of the if statement is this first line below it. And you can find code where they will not have curly brackets with an if statement, and there's only one line below it, and that line executes properly because it's automatically associated with that if statement because it's the first line after the if statement. If you intend more than one line to be associated with that if statement, it must have the curly brackets. I strongly recommend that you use them even if you only have one line of code that's associated with an if statement, because otherwise it gets very confusing and very, very difficult to debug. Okay, so let's go ahead and just finish up this little program. Else if I score greater than or equal to 50. Actually, we don't even have to do that, do we? Well, yes, we do. So we're actually being really generous here. Oh, you know what I did? I'm throwing myself a loop here. It should be D. Sorry. Um, well, below D is an F, right? So we don't even need an else if. All we have to do is say else, which is the catch-all, because there is only a D. Now, if we have, obviously we're using plus and minus grades, that would be an issue. So we'd have to put in more if statements. So I can just say else, cout, cout, failed course. Okay, and so there is our completed program. The reason I don't have to put an if on this one is because if this fails in short if this is not true and 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 everything else is not true, at the end whatever is left has to be true. And so we execute that. Now, and pretty much, that's how that works, and that's how an if statement works. We could do nested if statements, which will be another subject, but this is an example of a chained if statement. And as I mentioned in my note, this is not always the best way to do things. Sometimes it is, sometimes it isn't. But that is something you'll learn as you become a more proficient programmer and is beyond the scope of what we're doing.